Hello all, welcome to my channel. In one of my previous video, I had discussed how Iceberg uh, now supports geospatial data, namely geography and geometry. So while I was creating that video, I also happened to work on a project where I was working with geospatial data, and the framework that we use or my team uses is Apache Sedona. And hence I thought, why not introduce this to people who are interested in knowing how to work with geospatial data. Geospatial data is, or spatial data is a kind of a data which points or which provides a coordinate on Earth's plane or Earth's sphere, so that we can calculate few things. For example, one example of a geospatial data use case can be that, let's say the cell towers are there, and we want to find out the geography which is being covered as of now by a cell tower. Or let's say if we want to place a new cell tower, how or where it should be placed so that it covers the maximum users, plus it does not overlap with some other towers zone. So that way we can uh, place the telecom towers at certain location in a particular area, that will help us reach more and more customers. So for that, we will need the distribution of data, population density data, and other kind of stuff. And then we will need the geographic data is superimposed on that. For example, we can create an S3 index, which is a hexagonal shape that we can place and map the whole world by different what you call zoom levels or resolution levels. Like it starts with 0 and it goes till 16. So that way we can create uh, or we can leverage spatial data to run certain business cases that we have. Uber uses S3 index, and Uber created that, and they also do geospatial data analysis for their drivers, for their coverage. Telecom, as I mentioned, telecom companies do that for finding out the telecom coverage. Um, then there are a lot of companies who do it for finding out wildfire cases in US and Europe. It also serves well for people who are trying to get climate data or climate related data superimposed on the map so that it can be displayed for people to, like, for example, flood zoning or earthquake zones. So that way there are different use cases. So let's get started on the Apache Sedona part. So because this data is different, as I was mentioning on my previous video as well. This data is something which is, not, I will say, special, but it is something which was not part of the regular data engineering or data analysis work that we do, because there we have tabular data or some kind of structured or semi-structured data that was there. This is a totally different kind of data, and hence it requires a different engine or different kind of library to run this run the uh, analysis on top of it. For example, let's say if we in geospatial data we have TIFF files, geotiff files, we have raster files, we have weather data coming, let's say in HRRR extension. So there are different types of files that are there. And let's say, for example, raster data is nothing but a compilation of layers on top of each, and we will have cells or spaces, and then they have their different what you call attributes attached to that. So that way we have diverse source of data that are diverse types of data. So Sedona is something which was thought of as a solution that will help us in doing large scale analysis of this geospatial data. And it does so by extending the functionality of existing distributed frameworks. Like we have Spark, we have Flink, we have Snowflake. So Sedona, for example, Sedona Spark, which was earlier called the GeoSpark, can be used with Spark to work and do the distributed processing of geospatial data. Then we have Flink that can be used. We have Snowflake, and for that we have Sedona Snow. So that can be installed as a marketplace, or we can install these functions. Like these are the basic functions that get installed on or get deployed on Snowflake environment. So when either you can just place the jars, create an external stage, point that definition of the UDF pointing to these jars that you have, and that way also you can create. But this is also available as marketplace. I think there is a company called Warebots which offers this as a marketplace item, but it is free. It's something which is you can look at. And as I mentioned, there are a few things that it does. It offers spatial SQL analysis. It offers spatial Python interface. It also works with Java and Scala API functions. It can do raster data processing. It can do stream processing. It has also a concept of vector processing. This vector is different than the LLM vectors. This is vectors in terms of uh, 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 in terms of spatial data. And then it will do optimization, it will do aggregations, it will do a scalable spatial data index that it can create. So that way this offers these capabilities. And as I mentioned, it can run on Spark, it can run on Flink, it can run with Snowflake, it can also run with single instance environment like Python, or it can also work with Docker environment. So these are a few things to know about it. The architecture wise, it has three layers. uh, Basically, one is the spatial query processing or interfaces. So we have interfaces for SQL, interfaces for Python, Java. Then there is a distributed algorithm which understands the query that you have, and then it will translate and it will split the work. And it will also have an optimizer, which is a spatial query optimizer. Why we need a spatial query optimizer, which is different than Spark? Because this data structure itself is different. For example, let's say when we have a Parquet file, we calculate mean and max for a certain column, put that in the footer, and then we understand, okay, what needs to be skipped and what needs to be looked at. Similarly, for an let's say if we have an image data, weather data, so there also we need to calculate certain mean max or certain means like for example coordinate location. So if we are talking about, let's say we have a certain latitude and longitude, and we are interested in a range of lat and longs, so how do we do that in a what you call a spatial data set? So that is something which is requires a different kind of optimizer, and that's where Sedona kicks in and it does its job. Then we have a distributed data set layer. So what it does, it splits the data which we load into what you call chunks that can be processed individually by different workers which are there. So the same concept that we have with data frames, but because data frame was tabular data and it was easier for us to split, let's say based on certain row, the atoms. So we can say row 1 to 10 is belonging to executor 1, row 10 to 100 belonging to someone else, some other executor. But this data set that we have, let's say we have an raster file, to split that in a splittable format so that it can be consumed parallelly. And let's say for example when we have a large data set, let's say we have one whole picture of Earth's view, and then we want to split that so that it can be processed individually by different users, so that the algorithm to partition that has to be different. And that's where this distributed dataset layer helps in creating those partitions. It also helps in creating those indexing. As I mentioned, this is a different data type, so it requires a spatial data compression, a spatial data serialization. It does. Sedona has a cryo serializer for the data types that it works with. It is easy for Sedona to transfer the spatial data between executors because it uses the data, spatial data compression and serialization techniques, and also it provides a distributed representation of the spatial data. So that is something that it does. And then we have a distributed compute engine. That is something we have already talked. We can have Spark, and that Spark is not only, well, let's say it can run on EMR, it can run on DBR. I think Sedona can also run on Dask if we slightly tune it, because Dask is something which allows us to make any Python function as an distributed function. So Sedona can also be used in there. There is a GeoDask, GeoPandas Dask API. Similarly, we can use Sedona as well with Dask. And Flink and Snowflake, as I mentioned, Flink has a plugin, means jar that has to be there, and Snowflake, as I mentioned, we can define the functions pointing to the jar which is sitting in the stage. So this is the total layer-wise structure. Then we have something that we do is for how spatial query is processed. So what it does is the flow will be like Apache Sedona will first load the from different sources which are there. For example, it can load zip files, it can load GeoJSON data, it can load Parquet, GeoParquet, GeoTIFF, and CSV data, and then it will convert these files data into an in-memory distributed spatial data structure, or which is we can call it a spatial data frame. Then on that data frame, it will create a spatial indexing. So to accelerate the query processing, the indexes can be R trees or quad trees. It can also be H3 indexing that we talked about. Then it will also create the spatial index. It will use those spatial index to partition the data into smaller manageable units and can be processed parallelly. Uh, it supports complex spatial objects like vector, geometries, trajectories. It also supports raster images with map algebra. And as I mentioned, CSV, TSV, WKT is one another file format which is called uh, well-known text, well-known binary, GeoJSON, shapefile, GeoTIFF, RGRADE, NetCDF. So there are different file formats that it can work with, and it can take the data and process it. Uh, and also it executes everything in a distribution fashion. So what it does, it will split the work into smaller units, and then it will give this to the execution engine, and then those query will be executed on that, and then it will be collected back, and then response will be shown back to the user. Uh, Query optimizer in this case determines an efficient query plan by considering the spatial predicates available in. For example, it also supports, as we have in Parquet files, or let's say the files, different V2 sources of file which are there in Spark, which supports predicate push down, particle, what you call projection push down. So those push downs are also available with spatial data in Sedona. Uh, then it does the distributed spatial queries, like spatial queries is with range queries, range join, intersection, whether one what you call one shape intersects with another shape, one thing is contained within a particular polygon or not. So those kind of queries we can run, and we can use those to uh, process the data that we have. It also supports visualization tools like Kepler-GL or DeckGL that we can use to create, for example, if you are working with pandas or Spark, you have concepts of Plotly, Matplotlib, Seaborn. So similarly, we have different tools which are specific for spatial data. Kepler-GL is very much famous in that sense. And Sedona also integrates with Python tools like Jupyter Notebook, GeoPandas, Shapely, so that we can use those. For example, if we have GeoPandas data, we can convert it to Sedona data frame, and then vice versa as well is possible. But keep in mind, GeoPandas is one single node process. So wherever we are running, it will run on driver most likely when we do a convert of GeoPandas to Sedona. So that is something that we have to take into consideration. And this is how we can use this to run it on a Spark cluster. So we need to create a Sedona context which takes Spark context. But if you are already running in this in let's say EMR or somewhere where you already have a Spark context, then you can just simply and to plug this Sedona configuration into that session, and then you can use this as it is. So this is one simple example where we are reading a the bike taxi or bike trips data and neighborhood of NYC, which is New York City. So we just load that like Sedona.read format it is Parquet, but it can be anything that we want. And then we have a SQL query that we want to run. So we are doing a join on something, and then are checking whether the geometry contains the geometry of the other side of the table. So that's how we do a join. And then there is a concept, there is a new project a sub-project of Apache Sedona is called Sedona DB. Sedona DB is a high-performance dependency-free geospatial compute engine built in Rust. It uses data fusion, and it runs on a single machine. So as of now, it runs on a single machine, but it can be later on made distributed. I think most likely it will be. I believe companies like Dask or maybe Daft will take it up and make this parallelizable by using their engine, or someone else can also do that. Not sure, but it is this as of now it is single node, but there are discussions in the Apache community that it should be in a distributed fashion as well. So we can expect it to be running anytime soon. So that is something we can expect out of this project. And there are other special what do you call processing projects which are interesting. For example, GeoTrellis, which is an Scala-based solution which allows us to run a spatial computation in a distributed framework, and it uses Apache Spark to do that. But it is specific to raster data. It is mainly for raster data, but it can be there are some places where we can use it for other purposes as well, but it is specific to raster data. Then we have GeoWave. So this is faster serving or doing a processing as well, and because it uses backend of Redis and RocksDB. Then we have raster which is nothing but an raster specific package that allows us to work with raster in a more intuitive, human friendly way. And then there's a project called GeoServer. This is an open source project of, I think, OSGeo, which is an open source geospatial data processing forum, which supports a lot of other projects. And in one of the projects, project projects is GeoServer. It is very much used for serving geodata. For example, let's say if we have a raster file that we want to serve it to other people to consume it, or we want to serve it as an application. So it offers both. It has different components like WFP, WCS, sorry, WFS, WPS, which is web server for file transfer. Then we have processing service. We have so there are different services which are there, which are there as a module, and we can select and then use that as and when we want. So this was it. This was a brief introduction of how Sedona helps us in processing geospatial data. So yeah, that's it for this video. And apologies for any water sound that is coming. It's heavily raining heavily outside, so apologies for that. And if you like this video, do share it and spread the word. Thanks. Have a nice day.